Hola, mi clase. We're doing 12.2. It's called the converse of the Pythagorean theorem, not like the shoes. I can use the converse of the Pythagorean theorem to prove a triangle is a right triangle. So we've been working on just using the Pythagorean theorem, a squared plus b squared equals c squared, and that's only when we have right triangles. So what the converse allows us to do is if I don't know if the triangle is a right triangle, I can use a squared plus b squared and see if it in fact does equal c squared. And if it does, then I've proven it's a right triangle. So it's the backwards version. The Pythagorean theorem says if it's a right triangle, then a squared plus b squared will equal c squared. This says if a squared plus b squared equals c squared, then the triangle is in fact a right triangle. So it's before we know it's a right triangle. Okay, we're still using a squared plus b squared equals c squared. We just don't have to find any missing pieces this time. So that's what's kind of nice about this one. So it says tell whether each triangle with the given side lengths are a right triangle. So here's A. It gave us 90 inches, 40 inches, and 41 inches. And we already labeled it for you and said let A equal 9, B equal 40, and C equals 41. Remember, C does always have to be the longest, so that is why C got 41. But remember, A and B can be switched. So we're just going to take our Pythagorean theorem. We're going to go 9 squared plus 40 squared. And we're going to see, kind of go like this, question mark, 41 squared. Okay, that was a really bad squared, so I'm going to fix that. And what we're doing is trying to see if, in fact, these are equal. Okay, so this is where my calculator comes in handy because I don't know what some of these are. So 9 squared is 81. I do know that. And I know that 40 squared is going to be 1,600. And then again, we're going to see, does it, in fact, there's my question mark, equal 41 squared. 41 squared is 1,681. If we add these two, we get 1,681. Oop, I didn't write 81. 81. So it does equal 1,681. So we would say yes, right triangle. And that's all we have to do. So converse. So again, we have B. It says 8 meters, 10 meters, 12 meters. We always have to put the two shorter ones at A and B, and C must be the longest one. So we're going to go 8 squared plus 10 squared. Maybe does it equal 12 squared? This is 64 plus 100. Maybe does it equal 144? We get 164, which does not equal 144. So we would say no. Not right triangle. And that's the converse. So why don't you try this one down here? It says Katya is buying edges for a triangular flower garden she plans building in her backyard. If the lengths of the 3 pieces of edging that she purchased are 13 feet, 10 feet, and 7 feet, will the flower garden be in the shape of a right triangle? So I want you to pause and try this one and see if you can figure out where A, B, and C go, and then if they are in fact a right triangle. So hopefully you caught that 13 was actually the largest side and it should have been C, and that A could be 10 and that B should have been the other 7. Okay, now you could have switched these two, but 13 absolutely had to go into C. So we would do 10 squared plus 7 squared. Does it maybe equal 13 squared? We get 100 plus 49. Does it maybe equal 169? We get 149. Does not equal 169. So we would say no, not right triangle. All right, that's the converse. All right, try this one too. Pause. I want you to try a triangular piece of glass, has sides that measure 18, 19, 25. Is the piece of glass in the shape of a right triangle? And you don't have to explain. I'm not going to make you explain, but just tell me, is it a right triangle? I'm actually going to leave that one blank, and I want you to try it. I'm going to check for it next time, or next class. So Lashandra used grid paper to construct the triangle shown. Okay, so she used paper, grid paper, like a graph paper. Cut these out. It says, what are the lengths of the sides of Lashandra's triangle? So all we have to do to find the lengths is literally just count these. So 1, 2, right? 1, 2, 3, 4, 5, 6, 7, 8. So that one's 8 units. 1, 2, 3, 4, 5, 6 units. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. Okay, so that's the first thing, is just count the boxes. It says use the converse of the Pythagorean theorem to determine whether the triangle is a right triangle. So we know we have to use the two smaller sides. The nice thing is they also drew a triangle for us. We've been saying length and height. All right, so doesn't really matter. I'm going to go 8 here, 6 here. See my little question mark? They even do it too. 10 here. This is 64. This is 36. And this is 100. And then we put 64 plus 36. We do get 100 equals 100. And so the triangle Lashandra constructed is, circle that, a right triangle. So the main thing to remember is that if a squared plus b squared does equal c squared, then the triangle is a right triangle. Can't spell triangle today. Try angle. There we go. Alrighty, so that's the main thing to remember. So here are your practice problems. Tell whether each triangle with the given side lengths is a right triangle. And then I also want you to write the color red at the bottom and see who's listening with sound. All right, adios until next time. Oh, triangle. Oh, still can't spell triangle. All right, write the color red at the bottom. All right, adios until next time.